In this video, we will do further problems from exercise 3.9. Question number 5. In a triangle ABC, prove that A cos A plus B cos B plus C cos C is equal to 2A sin B sin C. So, we have a triangle ABC. Now, using the sine formula, we can say our A by sine A is equal to B by sine B is equal to C by sine C is equal to K. Some K, okay? Therefore, we can rewrite our A as K sin A and B as K sin B and C as K sin C. Now, let's take the left hand side. So, the left hand side, substituting A, B and C using the sine formula, we get K sin A cos A plus K sin B cos B plus K sin C cos C. So, taking the K, which is common outside, and let's divide it by 2. So, you will be multiplying all the elements inside with a 2. So, it's 2 sin A cos A plus 2 sin B cos B plus 2 sin C cos C. Alright. Further, 2 sin A cos A is nothing but sin 2A and this will be sin 2B. So, let's replace this first term as sin 2A plus sin 2B plus, let's keep the third term as it is. So, it's 2 sin C cos C. Right. Let's keep the K by 2 as it is. Now, sin 2A plus sin 2B is nothing but 2 times sin A plus B into cos A minus B. Okay, these two terms using the formulas that we have learnt in the previous chapters, plus 2 sin C cos C, we leave them as it is. Further, keeping the K by 2, now sin A plus B can be written as sin pi minus C, because A plus B plus C will be equal to pi, which is 180 degrees. Therefore, A plus B will be equal to pi minus C. So, we use this here and we say this is sin pi minus C into cos A minus B plus 2 sin C cos C. Next, sin pi minus C is nothing but sin C, because sin is positive in the second quadrant. So, this becomes 2 sin C cos A minus B plus 2 sin C cos C. So, we have a sin C common. So, let's take that out. So, this becomes K by 2 sin C, actually 2 times sin C, because you have a 2 common on both, into cos A minus B plus cos C. So, your 2 will be now cancelled. So you are now left with k sine c, and within bracket you have cos a minus b. Now c can be written as pi minus a plus b. So we call this as plus cos pi minus a plus b, and we close the bracket here. So this, further simplifying, this is k sine c, within bracket you have cos a minus b. Now cos pi minus a plus b will be minus cos a plus b, because cos is negative in the second quadrant. So this will be minus cos a plus b. Again, cos a minus b and minus cos a plus b will be equal to 2 sin a sin b. So this now becomes k times sin c into 2 times sin a sin b, which is equal to 2k sin a sin b and sin c. Now we have seen earlier that 2k sin a is nothing but our a. So this is equal to 2 times a sin b sin c, which is equal to the right hand side, hence the proof. Question number 6. In a triangle ABC, angle A is equal to 60 degrees. Prove that B plus C is equal to 2A cos B minus C by 2. So what is given to us is angle A is equal to 60 degrees. Now let's take the left hand side. Now the left hand side is B plus C. Now we can write B as 2R sin B and C as 2R sin C, since B by sin B is equal to C by sin C is equal to 2R. Okay. So let's take the 2 which is 2R, which is common outside. So this becomes 2R into sin B plus sin C. Further, we can write sin B plus sin C as 2 times sin B plus C by 2 into cos B minus C by 2. Now what is B plus C by 2? B plus C by 2 can be written as pi minus A by 2, because A plus B plus C is equal to pi. Therefore, this becomes 4 here. We can take the 2 out. So it's 4R into sin B plus C by 2 can be written as pi by 2 would be, this is a 2 here, pi by 2 would be 90 degrees. So 90 degrees minus A by 2 into cos B minus C by 2. Then this is 4R into, since our A is 60 degrees, this will be sin 60 degrees into cos B minus C by 2, which is 4R sin 60 degrees is root 3 by 2 times cos B minus C by 2. Let's call this 1. Let's now take the right hand side. Now the right hand side is 2A cos B minus C by 2. So the A can be replaced with the 2R sine A. So, this is 2 times 2 or sine A into cos B minus C by 2. A is 60 degrees. So, this is 4r into sine 60 degrees into cos B minus C by 2. Sine 60 degrees is root 3 by 2. So, this is 4r into root 3 by 2 into cos B minus C by 2. This is 2. So, from 1 and 2, LHS is equal to RHS, hence the proof. Question number 7. In a triangle ABC, prove the following. The first question is A sine A by 2 plus B is equal to B plus C into sine A by 2. So, let us consider A by B plus C. We know that we can write this as 2r sine A divided by 2r sine B plus 2r sine C, since A by sine A is equal to 2r, where r is the circumradius of the triangle. So, further let us take the 2r out into sine A divided by 2r into sine B plus sine C. So, the 2r and 2r will get cancelled. So, you are left with sine A divided by sine B plus sine C. Using the double angle formula, we can say sine A is nothing but 2 times sine A by 2 cos A by 2, and the denominator, which is sine B plus C, sine B plus sine C, can be written as 2 times sine C plus B by 2 into cos C minus B by 2. So, let us keep the numerator as it is. Let us cancel the 2's. So, this becomes sine A by 2 into cos A by 2 divided by our sine C plus B by 2 will now become cos A by 2. We have seen that in the previous sum, into cos C minus B by 2. So, these two terms will get cancelled. So, now you are left with sine A by 2 divided by cos C minus B by 2. Now, cos C minus B by 2 can be written as sine 90 minus, let us say this, sine A by 2 in the numerator. Let us keep that as it is. Now, the denominator, sine 90 degrees minus C minus B by 2. This is the same as cos C minus B by 2. So, sine 90 minus C minus B by 2 is now, let us keep the numerator as it is, sine A by 2 divided by sine. Now, the 90 can be written as A plus B plus C divided by 2, because A plus B plus C is 180 degrees. 180 divided by 2 will be 90 degrees minus C minus B by 2. So, keeping the numerator as it is, sine A by 2, and in the denominator, further simplifying this, this becomes sine a plus b plus c minus c plus b divided by 2, which is sine a by 2 in the numerator divided by sine c and c will become cancelled. So you will be left with a by 2 plus b. So this implies a by b plus c is equal to sine a by 2 divided by sine a by 2 plus b. Now further cross multiplying this becomes a times sine a by 2 plus b, so a equals, taking the b plus c to the other side, this becomes b plus c into sine a by 2, which is LHS is equal to the RHS, hence the proof. Part 2 of question number 7. So again, in a triangle ABC, we have to prove that A cos B plus cos C is equal to 2 times B plus C into sine squared A by 2. We have seen from 1 that A by B plus C is equal to sine A by 2 divided by cos B minus C by 2. So let's keep this as 1. Now let's take 2 sine squared A by 2 divided by cos B plus cos C. So let's keep the numerator as it is, which is 2 sine squared A by 2, but the denominator, let's expand that as 2 cos B plus C by 2 into cos B minus C by 2. Again, cos B plus C by 2 is nothing but sine A by 2. We have seen that in, I think, question number 6. So let's replace cos B plus C by 2 as sine A by 2 cos B minus C by 2. So our 2 and 2 will get cancelled, and one sine and this will be cancelled. So you will have now sine A by 2 divided by cos B minus C by 2. So this is 1. We can say from 1 and 2, A by B plus C is equal to sine squared A by 2 divided by cos B plus cos C, which implies A into cos B plus cos C is equal to 2 times B plus C into sine squared A by 2. Therefore, LHS equals RHS, hence the proof. Part 3 of question number 7. In triangle ABC, prove that A squared minus C squared by B squared is equal to sine A minus C divided by sine A plus C. So let's take the left hand side here, which is equal to A squared minus C squared divided by B squared. we know we can say A as k sine A. So, A squared will become k squared sine squared A minus k squared sine squared C divided by k squared sine squared B. So, this will now become, since k squared is common, we can eliminate it. So, this becomes sine squared A minus sine squared C divided by sine squared B. Now, sine squared A minus sine squared C can be written as sine A plus C into sine A minus C divided by sine squared B. Now, we know that A plus C is equal to pi minus B. Therefore, we can rewrite sine A plus C as sine pi minus B into sine A minus C divided by sine squared B. Sine pi minus B will become sine B, as sine is positive in the second quadrant, into sine A minus C divided by sine squared B. So, taking away sine B and one sine B from the sine squared, here you get this as sine A minus C divided by sine B. Further, we can write, we'll keep the numerator as it is, the denominator sine B as sine pi minus A plus C. I am putting a line here, which this means these two are within brackets. So, again sine pi minus A plus C will be sine A plus C. So, this is equal to sine A minus C divided by sine A plus C, which is equal to RHS, hence the proof. Part 4 of question number 7. Now, let us take the first term and let us take the numerator of it, which is A sine B minus C. So, we can expand sine B minus C as A into sine B cos C minus cos B sine C. Next, let us keep the A as it is, and sine B we can rewrite it as B by 2R, and then cos C, let us write that using the cosine formula. It is A squared plus B squared minus C squared divided by 2AB minus, again sine C, let us call that as C by 2R, and our cos B will become A squared plus C squared minus B squared divided by 2AC. Next, let us cancel the common terms. B and B is common, and here the C and C are common, and let us take the common terms out. So, we can take the 2R, and with this 2 it becomes A divided by 4R, and you have A here, taking the A also out. So, we are left within bracket A squared plus B squared minus C squared minus A squared minus C squared plus B squared. A and A again will be cancelled. So, it is 1 by 4r into, cancelling the common terms, a squared and a squared will get cancelled. So this will be 1 by 1 minus 4r into 2 times b squared minus c squared, which is nothing but 1 by 2r into b squared minus c squared. This implies that a sine b minus c is equal to 1 by 2r into b squared minus c squared, which implies a sine b minus c divided by b squared minus c squared is equal to 1 by 2r. Let's call this 1. Now let's take the second part of the question, which is b sine c minus a, and let's use the same method as the first one. So this is b into sine c cos a minus cos c sine a. Further, b, let's keep the b as it is, and for sine c, let's replace that with c by 2r, and for cos a, let's use the cosine formula, so that becomes b squared plus c squared minus a squared divided by 2bc minus, now the sine a will again become a by 2r into, our cos c will be a squared plus b squared minus c squared divided by 2ab. Close brackets here. Again, cancelling the common terms and bringing out the terms outside. So it's b divided by 4rb into b squared plus c squared minus a squared minus a squared minus b squared plus c squared, which is equal to, the b and b will be cancelled. So that's equal to 2 times c squared minus a squared divided by 4r. So this becomes c squared minus a squared divided by 2r. So further, this would mean that b sine c by a divided by c squared minus a squared is equal to 1 by 2r, and which is 2. Similarly, we can prove that c sine a minus b divided by a squared minus b squared is equal to 1 by 2r. So from 1, 2 and 3, we can prove a sine b minus c divided by b squared minus c squared is equal to b sine c minus a divided by c squared minus a squared is equal to c sine a minus b divided by a squared minus b squared. Hence the proof. Part 5 of question number 7. So in triangle ABC, prove that a plus b by a minus b is equal to tan a plus b by 2 into cot a minus b by 2. So let's take the left hand side, which is a plus b divided by a minus b. Now let's apply using the sine rule. Replace a with 2r sine a and b with 2r sine b divided by 2r sine A minus 2r sine B. So this is taking the common terms out. You have now sine A plus sine B divided by sine A minus sine B. The 2r is common for both the numerator and the denominator. So this sine A plus sine B can be written as 2 times sine A plus B by 2 into cos A minus B by 2. Similarly, we can write sine A minus sine B as 2 times sine A plus B, sorry, this is cos A plus B by 2 into sine A minus B by 2. So we can put them within bracket. Now sine A plus B by 2 by cos A plus B by 2 is nothing but tan. So the 2 and 2 will be cancelled. So this will become tan A plus B by 2, and cos by sine is cot. So this becomes cot A minus B by 2, which is equal to the right hand side, hence the proof.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.